In this video, we address the final prerequisite, which is to find the index of the smallest element of the array. So here we have the algorithm for finding the smallest element of the array. Let's see what changes we can do to this so as to get back the index instead of the index of the smallest element of the array instead of the smallest element itself. So the change in front of every change, I'm going to put a star such that it is easier for you to identify, right? So we're going to need a variable that would have a name smallest underscore index, and this would store the index of the smallest element of the array. Stores the index of the smallest element of the array. All right. Next, we are storing the smallest element here, right? Below this, we also need to, let's give it a star here, we also need to store the index of that element as well. So we have assumed that we are assuming the first element to be the smallest element, right? Therefore, the index, what is the index of the first element? 0. So that's what we store here. Now, when we are finding the smallest element, we are storing the smallest element in smallest. With that, we are also going to store the index of the currently found smallest element. So the index of the currently found smallest element is I, and this we are going to store in smallest underscore index. And that's it. These are the three changes that, if done, will fetch the index instead of the element itself. Let's see what changes we need to do for finding the index of the largest element of the array. So it's kind of the same thing actually. So let me change the color. So largest index, this stores the index of the largest element of the array. All right, let's put a star in front of it to mark that this was the change done. Then we are assuming the first element to be the largest element, therefore the index of the largest element now would be 0. All right. Now, when we have found out our current largest element, then here, when we have already found out our current largest element, with this assignment statement, we also need to store the position of the currently found largest element. Now, the position of the currently found largest element is I, and we are going to store that in largest index. And that's it. So let's see what changes we need to make in our program to cater for the changes we did in our algorithm. To cater for changes we did in our algorithm. So here we have a new class. This is basically a copy of the previous program. So here we have the smallest element and the largest element. These are the two methods where we need to change a few things. All right. So it's better that I add a comment here, assuming that the first element is the smallest, and then we would go on to store the index of the smallest element. That's 0. Now, when we have found out our smallest element, we will store the smallest element and we will store the index of the smallest element as well, and that is I. And instead of returning the smallest element itself, instead we would return the index, the smallest. Copied wrong. All right. So, and I'm going to change the name of the method as well. Smallest element index. Same thing we're going to do with largest element. We're going to change the name of the method first. I'm going to add a comment assuming that the first element is the largest. Then we're going to store the index equal to 0. And then when we have finally found out our largest element, this is our largest element. So I'm going to store the position of the largest element, which is I, in largest underscore index. Alright. Now, instead of returning the element, I'm going to return the index. Let's see what changes we need to do in our main method. So these two lines are going to be the same. We're making an object of the scanner class. We're making an object of this class, right? Then we're taking the size of the array as input. We're initializing the array, allocating memory to the array. Then we're taking input in the array. Now we need to find the index of the smallest element of the array, and that we're going to do by writing int smallest underscore index equals obj dot smallest element index. I'm going to pass an array. Same thing we're going to do here, finding the index of the smallest, index of the largest, I'm sorry. I'm going to copy the same thing, change smallest to largest, and smallest to largest here as well. Next, we're displaying the contents of the array, and then displaying the index of the smallest element of the array. The index of the smallest element of the array is smallest underscore index. Index of the largest element of the array is largest underscore index. Alright, so these were the changes that we need to make in our program. Mainly the changes are restricted to these two functions. These changes are the most significant changes of all. I'm sorry, these changes, right? The changes in the method largest element index and smallest element index. Let's compile this. No syntax errors, thank God. Let's run this program. Okay, so let's do something. Let's run this program on the array that we had been using so far, such that a similarity is continued. Okay, so enter the size of the arrays. That's 7. The first element is 38, 41, 18, 50, 68, 22, and 34. So the array is this, and the smallest and the index of the smallest element of the array is 2. That's true because 18 is the smallest element of the array. There is index of 2, 0, 1, and 2. And the largest element, index of the largest element of the array is 4. That's true because 68 is the largest element of the array, and its index is 0, 1, 2, 3. Alright, so I hope you have understood how to find the index instead of the element of the smallest and the largest elements. Hope to see you in the next one. Bye for now.